Systems life cycle. The systems life cycle is the process of developing and creating new software from start to finish. There are several system life cycle models. The key stages that you need to know about for the computing project are design, implementation, testing, and evaluation. The design has to be good enough so that others can implement your solution based on your plans. The designs need to have the following sections. It needs to have requirements, flowcharts, pseudocode, structure charts, description of the algorithms, a list of variable and lists, and also a graphical user interface if it has one. The implementation phase is actually writing the code and developing the solution. Good code will be highly modularized and have functions that complete a particular task. The code needs to have lots of comments and needs to be well annotated. Testing code is important to ensure that it works as desired and contains no errors. There are three types of errors that we really need to be concerned with. First of all, syntax errors. These are errors in the code that mean the program will not even run at all. Normally this is things like missing brackets, spelling mistakes and other typos. Runtime errors are errors during the running of the program. And finally, logical errors. This is where the program runs fine but the output is not what you would expect. We need to test our code with a range of different input data to ensure that it works as expected under all situations. Data entered need to be checked to ensure that the input values are within a certain range, in the correct format, the correct length, the correct data type, and so on. During testing, we'll test the program using normal, erroneous, and boundary data. So normal data are data that we would normally expect to be entered. For example, for the age of a secondary school pupil, we would expect integer values ranging from 11 to 19. Erroneous data are input data that are clearly wrong. For instance, if someone entered 40 for the age of a school pupil, the program should identify this as invalid. But at the same time, the program should be able to handle this sensibly, which returns a sensible message and the program does not crash. Boundary data are data that are on the edge of what we might expect. For instance, if someone entered their ages 11 and 19, it should be able to handle these values and recognize these as correct values. For the testing, a plan like this needs to be completed. Screenshot evidence of the output also needs to be presented. In addition, if any changes to the code have been made, it's really useful to have before and after screenshots. So the table consists of the test number. This allows us to refer to the screenshot evidence, which is put into another table. A test description, the data value that were actually entered, the data type, so whether it's erroneous, normal, and boundary, the result that we would expect to have if everything works fine, the actual result, so if everything does work fine, then this should be the same as the expected result, and also for the test to pass, the actual result needs to be the same as the expected result, and then no improvement will be needed. However, if the test fails, then we need to state what improvement needs to be made, and also we need to state what the actual output was. So the final stage is the evaluation, where we discuss the potential enhancements and refinements to the program. So we need to discuss how well the program met each of the requirements and any kind of improvements that we would make to it.